All right, I see a lot of people coming in here. How's it going, everybody? Yeah, so thanks for joining us today for the webinar. Yeah, I see a lot of people in the chat. Yeah, if you have any questions, feel free to leave them in the chat. Um, Nice to see a lot of folks calling in from a lot of different places. Yeah, so I guess with that, I can get started here. So, just a little bit about me. Just want to say thanks for joining today's webinar. I'm Leo Nguyen. I'm a senior solutions architect at Unity. Super excited to talk to you guys today about Pixyz Plugin and how it can make a huge difference in AEC workflows. A little bit about me, I've been with Unity for 5.5 years. And before that, I've worked in construction, architecture, and engineering. So I've seen firsthand how challenging it can be to handle very large, complex 3D models in a real-time environment. So that's where Pixyz will come in. It helps to bring very heavy CAD models and point clouds directly into Unity, making it very easy to work with real-time visualization or collaboration or AR and VR. So I'll walk you guys through, how Pixyz will fit into your guys' project and how we can streamline the imports to optimize for, very large data set. And just to, yeah, so just very excited to go through all that with you guys today, and how we can essentially take 3D data and make it more interactive in Unity using Pixyz. So before we get started, maybe if you can just put in the chat, what are you guys' use case with AEC, working with that sort of data set? Is it, for visualization? Is it for, rendering, or is it for collaboration or AR and VR? Maybe you guys can just start with that and sort of let me know, and then we could go from there. All right, I'm going to start sharing my screen here. So while I'm presenting, I will mostly rely on the other folks on the call to help me with the questions. But yeah, feel free to leave them in the chat, and then we can take a look at them afterwards once I go through the presentation. So I see a lot of use cases around simulation, AR, VR, animation, large architectural data, oil and gas, 3D visualization. So yeah, CAD models, requiring LEDs. So yeah, perfect. That's really exactly the use cases that we have in mind when using Pixyz and working with a large data set. All right, so I'll start in here. I hope everybody can see my screen okay. So right now I'm inside of the Unity editor, and I have a model already loaded here. But just to walk through the import process, so when you start a new scene, essentially you will have an empty canvas. From there, you can start with the import process. So down here at the bottom, we have a button that will show us the import CAD UI. So when I click on that, I can select the Revit files or IFC files. We also support SketchUp, and then the other file formats. That's more general 3D file formats like FBX or OBJ. We can also load in point cloud as well. So any of those files will work. So once we have a file, we can go ahead and select that and then hit open. So I already have one here open, but I can go ahead and then, for example, select the architectural file and go ahead and open that one. So when you open up a file in Pixyz, what you have access to is the set of rules that you can import. So for example, in this file, I have the ability to set the scale, the orientation, importing of the metadata, the different prefabs, and then we can also set the mesh quality. So right now I have it on high. I can go ahead and re-import or import if it's a new model. And then I can also run rules on that model. So let's say if you have multiple versions of it, you want to be able to quickly update, you can apply the rule engine to that. And then also you can use LODs as well. So I'm going to go back here into my scene and take a look at the different files that I already have imported here. So a little bit about this one. I'll go ahead and make this full screen here. We could fly around and take a look at this one. So you can see here down below, we have the statistics. So this is a model with about 30,000 different game objects. It's got 17,000 renderers and about 1.5 thousand meshes. And then in terms of the triangles, it's a relatively larger size file. So it's got about 363 million triangles. So, in order to optimize a model of this size for AR and for VR, Pixyz is really essential, during that workflow and in that process of making something like this ready to be, viewed on a lightweight device like a Quest 3, for example. So let me go back into my scene here. So, as I fly around, I can take a look at the model. So we're able to bring in the architectural core and shell, as well as all the structural elements inside of the model. So it's taking a translation of what I have inside of Revit directly one-to-one. So it will preserve all the scaling, all the different materials. So for this one, there's not a whole lot of materials since this is mostly just the core and shell and the structure for this airport model. But you can see that there is a quite high polygon count, triangle count on this model, simply because oftentimes for Revit and other BREP modeling design tools, it's for construction and engineering purposes. So the polygons coming in, they're not as lightweight and well optimized. So that's where we would, take it into either the Unity environment here using Pixyz to optimize for it. We also have other tools for Pixyz, Studio, and then SDK. And actually, Brian Bear will be covering SDK on the next webinar. But for today, it will mostly be about Pixyz plugin within the editor. So you can see once I bring it into the Unity environment, I have the ability to preserve all the different hierarchy that's coming in from Revit. So this is all the categories structured in the parametric design of Revit. So we will preserve that one-to-one. So all the parent and child hierarchy will be preserved. So for example, if I want to take a look at the information on this roof, when I select that, it will pull up that element. So this is a concrete metal deck. It's got two materials on it. It's also got a metadata component. So this is all the information coming in from this element from Revit. So it belongs to the floors category. There's a whole bunch of other metadata that we could also leverage as well. So you can see the family, the type, different constraints, additional information on the type and identity. So this is metadata that we could also change on the Revit side so that we could leverage this metadata once we have it within the Unity environment. So you can see here that when I move around with this size of a model, we will certainly need to optimize this. So down here in the toolbar, we have options to, for example, this one here, to merge different components together. So if you don't need to have all the different specialty equipment on the same like individually, um, individually, like separated, what we can do is we can go ahead and merge them together either by level or by floor or by the category that they belong to. So using the merge method, we're going to be able to bring down the number of game objects within the scene. So essentially by doing that, we will be able to reduce the number of batches and draw calls that the CPU will have to send to the GPU. And you can either use, the merging component. You can also use, static batching within Unity as well. So those are just some handy ways to, reduce the number of draw calls, that the GPU has to do. Um, so yeah, so using the merge tool, you can also explode a model as well. So let's say certain elements coming in might be grouped together because it belongs to the same family. Inside of Revit, what we can also do is select one of those and then also be able to explode that model. Maybe we need to modify that system or have the ability to pick out certain specific elements, make it a prefab if we want to spawn new ones. So those are some other ways to optimize for the model. So let me actually switch over here to another scene that I have. So for example, I'm going to use one of the other scenes that's got so this is actually another architectural Revit sample. So this is from Autodesk. So let me go ahead and open this up. You can go ahead and fly in and take a look at this. So it's about it's a 4-story model. It's got architectural, structural, a bunch of other specialty equipment. So for this model, there's about 19,000 game objects and about 30 million triangles. So for something like this, what we would want to do is, be able to optimize this. So we could go ahead and start merging the different components together. So if I select the architectural file here, I could go ahead and select, level 1 and go ahead and merge that together. So let's say if you want to do a sequence of construction to show how the building will be constructed based on the levels, like level 1, level 2, level 3. Just to give an idea of the stages of construction, what you could do is go ahead and select that level and then go ahead and run the merge optimization. And when you go ahead and hit run, it will actually combine all the different meshes in that level together. So you can see here that once we have it combined, it will share the same materials. So by doing so, we're able to reduce the batches, essentially number of batches where the CPU will send the GPU information of what to render. So if a scene has about for example like 100 objects, the CPU has to send about 100 draw calls to the GPU. So by grouping those together, the GPU doesn't have to work as hard. So yeah, and then using that method, we're able to increase the frame rate as well, because more things that needs to be rendered will essentially reduce the number of frames that you have. So you could go through this and start combining your levels together, and then you could use that information to build a sequence of construction. So let me go ahead. So take a look at the scene here. We started with 19,000. So now I'm able to bring this down to 16,000. So if I go ahead and hit play here in the editor, so right now we're saying about 15,000 batches and 27 million triangles. And when I go ahead and hit play, you're going to notice that with the FPS, it's not going to be super great if you are working with this within a lightweight headset like the Quest 3. So right now it's I'm only getting about 25 FPS, you know, with no occlusion culling or no frustum culling. So, you know, that's not that great. If if you bring this into VR, the experience is not going to be very smooth. So, you know, I could move my camera back and forth here, but, you know, you notice that the frame rate will jump depending on where I am within the scene, but it sort of hovers around the 20, 25, 26, just because of, you know, how many game objects and how many triangles that we have on this model. So let me get out of play here, and then I'll switch over to a scene that I have already optimized by just merging all the different levels and components and specialty equipment together without any decimation. So we're not losing any, any level of detail on the actual object itself. So we're just doing just raw merging alone. So let me switch over to this scene here. So with this one, once we have all the different components merged together, we're really able to bring down the number of game objects. So when I switch over to this other scene here, you can see that now we only have 31. So this is just a decimation of the levels. Of course, you don't have to do it by levels. You can do it by category, or really any combination of different game objects. So if you're looking to maybe focus more on the architectural, and you don't need to have all the electrical or plumbing fixtures as separate pieces, you can just combine that. So in here you can see that I'm still retaining the number of triangles, but the number of game objects definitely went down. So if I go ahead and hit play here in the editor, we can see that the number, the frame rates that I'm getting is going to be much better, because we're sending a lot, less draw calls to the GPU. So when you can see here that now I'm hovering around 120 FPS. So this is optimal for VR visualization. If we need to take this into a Quest 3 device, whether it's tethered or in standalone, as an APK, on an app. So I could move my camera around here, so you can see that I'm still getting pretty good frame rates, and this is without any occlusion culling or any frustum culling. So, once we have, all the different game objects merged together, we can also, decimate them as well. So, you can either do, you can also topologize certain components so that you have better consistency for the model itself. You also can, and I would recommend, doing rewatologies on high density models, so that you can simplify the mesh, reducing the number of triangles. Some of the other tools that we have access to is also the decimation. So you could set the target, either it's quality, or you could specify a specific triangle count. So if you need this one, for example, in this model, if I want to, for example, in level 1, I want to take this down to 500,000. I could specify that in here and go and hit run, and Pixyz will go through and then decimate the number of triangles I have on this object. So there's a lot more optimization that you can do in terms of creating different level of detail, so that you could use it inside of your real-time application. I'm gonna jump over and show a few other examples of the other type of data set that we can work with. So let me switch over to a point cloud example that was submitted. So Cam actually showed this on the previous webinar, but essentially what we have here is I believe on this one, it is a 30 million point file. It's about 600 megabyte point cloud. So you can see here that Pixyz will read an E57 file, and once we have it, we could bring it and drop it directly into the Unity environment. And then from there, we could fly around from a first-person view, really examine the point cloud. So this is from a terrestrial scan. And just the viewing experience in this is much, much better than what you would be able to do inside of Revit or inside of Navisworks, where for those tools, it's going to be mainly for the linking of the point cloud into the environment if you need to remodel this. But in terms of the viewing experience, you're going to notice, the difference between viewing this inside of Unity versus some of the other tools is that Unity is really real time, and we have the ability to, use this from a first-person view. Whereas if you were to use this inside of Navisworks or Revit, the experience is not going to be as great, and you're going to notice a lot of popping of different point clouds as you move around. And then in here, I could also start mocking out this environment as well. So if I need to, I could go ahead and, for example, create, different 3D objects that would represent the flooring or the walls, or I could create, like cylinders that would represent these pipes. So you can, work within Unity to create an as-built just from, being able to, just be able to visualize this within the Unity environment in a real-time, in a real-time manner instead of linking this back into more of a traditional design tool. And then, of course, once we have that all mocked out here inside of Unity, you can export that back. Either save it out as an FBX file, and then you can use it inside of your traditional design tools, or you can also use it as a 3D model for the visualization within Unity itself. So that's on the point cloud. And then we can also, use the point cloud to convert this into a mesh as well. So using the Pixyz toolset down here, I can convert this into a mesh. So using Pixyz, I can clean out the model. I can also take a look at the different point density. And then also when we bring it into Unity, we'll actually section out the point cloud as well. So you could use this in a frustum culling system or occlusion culling system. You can see here, it really gives you the ability to work with this and optimize the point cloud if you have much larger point clouds that you need to bring into Unity. So let me go ahead and get out here. So I could go ahead and show another scene that, that's already been converted into a mesh and has the different sections all, in individual tiles, so that we can implement sort of a frustum culling system so that we can improve frame rates if we want to, visualize many different tiles instead of just having like one tile that more of a smaller scene. So for this one, this is more of a terrestrial scans, and then the example that I'm going to show here, so this one's more on the aerial scan, so sort of a top-down view from a drone scan. So go ahead and just let this load here. Go ahead and jump into the scene view. So I'll go ahead and fly up here. So you can see here that in this model, so this is a aerial scan from a drone. It's got 153 game objects. So, quite a number of game objects tiles that we have here. So I'll go ahead and fly out. It's got 24 million triangles. The full data set is actually quite larger, but just for the demo, I'm only showing a portion of it. So this is me flying around. I can go ahead and get lower into the model. So you can really see the detail that we're able to retain from the model, from the point cloud to the mesh. And you can see here that there's a lot that we could do once we have it into Unity. We can, since this is a mesh, we can convert this, into a mesh with colliders. So if I want to do some sort of like training scenario in this region, I will have, colliders with physics enabled. So if you want to show, fall hazards, or you want to be able to show collisions with machinery, we can really start leveraging the, colliders that we can generate using Pixyz. So yeah, you can see that here that each tile is about, 1,000,000 triangles. So you can see here, once you can start to see that once we bring this into the Unity environment, and with all these tiles all loaded at once, it will start to bog down the performance of the system. Depending on the number of game objects, materials, meshes that we have. So you can see here that it's got different pieces. So let me go ahead and go back into the scene view, and then we could take a look at the game view. So over here is the game view, and then I'll go ahead and select my main camera here. So this is what the main camera is looking at, and this is what the game view is looking at. So in order to optimize this, we can also implement a very simple like frustrum cooling system. Or if you're working with more of an interior scene, you can go ahead and set up walls and then use the occlusion cooling system to hide certain models or components that's behind a wall. And then Pixyz will also let you merge by region as well. So for example, if I open up the merge tab here, I can see that I could merge by regions, I could merge by hierarchy level, or by name, or by material. So using a combination of the different merging tools that we give you, you could really optimize for the frustrum cooling system. So I'll go ahead and hit play here. Let me get a little bit lower into this so we could see this a little bit better. And hit play here. And if you notice, once I hit play with the frustrum cooling system enabled, we can hide certain tiles depending on where we are within the scene, so that our triangle counts will not exceed a certain a specific threshold. So I'll go ahead and select the camera here. So you can see here that in this view, as I'm looking this way, in the main camera view, I'm able to hide all the other tiles that's behind the camera. So as I rotate the camera around, the other tiles will start to disappear. So you can see here that when I click back into my view, there's only 5 million total number of triangles that's being rendered in the scene, because I'm able to use frustrum cooling system, along with the way that Pixyz will split up the model, so that I could hide specific elements within the scene if I'm not looking at it. So as I rotate the camera around here, so let me just move back here. I'll go ahead and rotate the camera around. You can see that it starts loading in the other tiles as I move. So you can see here that even with a file like this, I'm still able to retain 150 FPS with only 13 batches, just simply using a frustrum cooling system. So you can see here, as I move and rotate around, it will load in and out the different tiles that I have within the scene. And you can see that as I move the camera around, the game view will essentially be you're not going to notice all the tiles popping in and out, because that's behind the view of the player. So everything to the player will look pretty normal, because it's being rendered just by what's in the view of the camera frustrum. Go ahead and stop this. All right. Okay, so let me go ahead and jump over to an empty scene so we could go through, the workflow of some of the other tools that we have access to within Pixyz. So, I went over a couple of different, real world examples of files, much larger files that typically you would see within the AC environment, like a hospital, an airport, point clouds. So in here, I'm gonna just, for the sake of time, I'm gonna go and import a new file into this environment and walk through the process of taking a brand new file into this environment, and then how we could go through and utilize some of the other additional tools that we have within the Pixyz tool set. So let me go ahead and import a new CAD file. So I'll go ahead and use this one here. I already have this one created, but I'll go ahead and import a new one. So when I bring it in, I could set some of the parameters on like scale, the orientation, metadata, the mesh quality. I'll go ahead and hit import here. Once we start the import process, Pixyz will go through and start the transformation of the model. So go ahead and let that give it a second here. So that should be done. And actually, I just want to highlight another thing here is that for larger BIM files, what we could do is we could also we can also change the way that Pixyz will import the file. So if I go to these importer setting here, I can go ahead and open this up. I can go ahead and open this up in a debug mode. So essentially giving us the ability to go ahead and hit debug. So in here, I have the option to import this into the scene instead of importing into sort of your asset folder. And then that will actually make it a little bit faster with larger files if you just want to quickly visualize it. Go ahead and go back to the normal view. And once we have it inside of the environment, I can go ahead and drag this into the scene. Go ahead and hit F, so that will center the model for me. So this is just a very basic model coming in from Revit. It doesn't have a whole lot of textures or materials. So this is just to show, what else, what we could do with the model once we have it within the Unity environment, and making it more interactive. So you can see here that with the model, with the Revit model that I have, if I go ahead and select just a component on here, go and hit edit, edit type, I could see, the, additional like information on that metadata. So all this information we could pull through using Pixyz. So, any custom metadata that you would want to add, you can go ahead and, add that into this environment here. And then leveraging the metadata component on the Pixyz side, we could say, find me the model that contains this key. So just a dictionary with key pair values so that we could use it to search for certain items within the scene. Go ahead and jump back into the Unity environment here. So, once we bring it in, and also sometimes when you bring in a model, from Revit, certain families and categories that doesn't have any materials on it, or if you didn't assign anything, Unity will actually tell you that, hey, you got a missing, material. So it will actually have this magenta color. So if that's the case, you can go ahead and assign, create a new material and assign it. You can also, create like an action within Pixyz, or you could just, have a simple, editor tool that will also like fix the materials for you. If there's, a lot of materials that's not been assigned on the Revit side. So a couple different options you can do there. You can just go ahead and manually assign this. For example, if I go ahead and manually assign this, it will show up within inside of my scene. You can see here that once I bring in the model and assign material, I can now see it. And then any component that we bring into this environment, we can also change as well. So for example, if I want to select the one of the glass here, it will show me the glass component, the mesh on it, the materials that's been assigned. I can go ahead and select the material and then go ahead and it will actually highlight that in the scene for me. So when I go ahead and select that, it will expose the different parameters on that material. So I could see the, the surface type. This is a transparent material. The blending mode, if it's a opaque material, I could set the render to front, back, or both. So for this glass material, I just want to be able to change out the color on the glass here. So I'll bring this down to more of a realistic look. So now it's not this blue glass that I that's not maybe to spec of what I have on the actual material itself. And then, I can go ahead and, start applying additional materials to the model. So, let me go ahead, let me go back to the scene here. So for the first, I would say, optimization, let's go ahead and select, one of the generic stone here. So you can see that when I have this selected, I can, take a look at all the parameters that I have. I can also do some rules on this. So for example, if I want to, take this and replace this with, another material that I have on the Unity side. So I could go ahead and, create a new script inside of Pixyz. So this is a new rule inside of Pixyz. So go ahead and create, and then I could create a new rule set. I already have one here, so I'm just going to go ahead and select that one. And with this set one, for example, I could go ahead and search on this, or I could go ahead and get the model that I have already imported into my scene. So for example, if I just have this selected here, I could say, I want to be able to switch this, to a different material. So for example, if you bring in a model and you see that, on this, component, there's a lot of, different number of things that in terms of details that you might not want. What you can also do is swap it out for a, bounding box. So for example, in this example, I could select, all the stones that I have inside of, just this like retaining wall system. I could go ahead and do a replace by. So for example, I'll just go ahead and do like a bounding box. I'll go ahead and hit run. It actually will go through and replace the polygon that I have from the Revit side to a bounding box that I have. And then with this material that I have on the bounding box, it's just a default. I can go ahead and hit run. That will actually, bring the material, assign it, but you can see that there's something wrong with the material because it doesn't look right. So let me just go ahead and undo this. What I can also do is select all of that and then go ahead and create UVs. So by creating UVs, now we have UVs that the material can properly wrap to. So if I run this again, you can see that by adding the UVs, all the materials now has been fixed. So you can see that now the materials now look a lot nicer, more uniform to the structure that I have applied the material to. So in here, once we have the material applied to all the components that I want. I can go back into the material. I can also, change, some of the settings like the base map, the normal map. I can make it, more or less like smooth or bumpy. So for example, like the occlusion map, I can change this up to, mimic more of like a brick texture where it's, sort of popping out. So instead of having this as like individual, you know, bricks taking up like, essentially triangle counts within the scene, I could use the occlusion map to make it look more photorealistic. So that's on the material swapping side. So let's say I also want to be able to swap out this character as well. So with Entourage coming in from Revit, it doesn't look as great. They're just billboards cutouts. So let's say we want to be able to replace this with a higher visual fidelity character that we already have, or we might source from other tools or from the Unity Asset Store. So for example, in here, I actually have a character ready. So, you can see here, we can just go ahead and take a look at this character that I have inside of my scene here. So you can see here, how would we be able to automate the swapping of, the entourage from Revit to something that's, more high quality that we have within Unity, or maybe a character that we want to have animation, or you can also do it on other prefabs as well. So this would also be a good workflow for designing like a VR walkthrough, the entourage, or any custom metadata that contains a specific field could then be automatically swapped out for, say, a teleporter prefab, so that when we jump into like a VR environment, we could quickly use that as teleportation waypoints inside of that environment. So, so you can see here, I have a character inside of my scene. I'll go ahead and there's actually a few different ways on how we could create a rule for that. We could filter the model based on the name, the material, or metadata, or positions or tag. So for example, I'm just using tag in here. That could be a rule that we set, and then once we have the the character selected, we can either do it manually down here using the toolbar, or we can create a rule so that when we bring in a new model, we can just apply the rule to that model. So it's looking for a tag, and then I can go ahead and set the replace by, and then set either I can replace this into like a bounding box, or just a game object that I have. Usually, when I'm working with this, I would just go ahead and actually make a copy of this. So I'll go ahead and copy this, go out here, go ahead and paste my model. I'll go ahead and turn this back on again. So now we can see, now I have this entourage. So go ahead and go back to my set two, have this selected. So for example, if I want to just, replace this with like a bounding box, for example, I'll go ahead and hit, I could do like replace the rotation and the scale. I'll go and just hit run here. It actually will, add a bounding box in for me. And then from here, I could also, run the script to say, take a look at this, filter it by the tag, and then I can go ahead and swap it out with this character. So in the game object, I could set this character here. I already have it in my scene, or you could also set it as a prefab that you have down in the asset. Go ahead and hit run here. You can see that once I hit run, I could go ahead and turn off this guy. So now I have a new character that's been swapped out from the character that I imported using Pixyz. Or sorry, using Revit. So you can see here now I have a higher visual fidelity version that then I could, add animation or use it as part of my walkthrough inside of Unity. And then from here, let me go ahead and sort of fly around the model and take a look at some of the other minor issues that could happen with the model when we bring it in. So for example, this fire pit here, you can see that when we bring it in from Revit, there's an issue with this family in terms of the faces. So what I can do is select the model. I could go ahead and hit the create normals. So that will give me a normal map. I can also flip the normals. I can also go ahead and hit repair. So these are some of the other options I have. So when I hit repair, I'll go ahead and run this. Pixyz will go through and then repair the mesh. And then I can go ahead and hit conform normals. I'll wait for it to finish repairing here. And then I could go ahead and hit conform the normals so that once we hit the conform normals, it will, flip. Oh, okay. And then, we will get proper normals on the fire pit here. So, you could do that. If it's individual items, for example, like this fire pit here, I could, select the precast. So I could either do that using the Pixyz tool, or I could also set the rendering on this component as well. So when I select that material, I could set the surface type to opaque. Then I could set rendering to both. So now, you're not looking through the actual fire pit. So that's an example of some of the other additional tools that we can work with. And then I also have some other examples of Z fighting that I could also fix inside of this Unity environment as well. So for example, like on this component, I'm getting a bit of Z fighting, so I can go ahead and select that component. Go to remove Z fighting, go and hit run. It actually will bring it out. And then from there, I could go ahead and just adjust it that way. So, just some additional tools, Pixyz will give you in terms of optimizing the model itself. So let me see what else I can cover. So yeah. So yeah, that's how to work with some of the other additional tools that we have within Pixyz plugin. So you could either do it manually here, or you could create a set of rules. And then of course, you could also extend it by using custom Pixyz actions as well that could be created to optimize the model, the import process, and then making it much more automated if you need to re-import and bring in additional data into the Unity environment. So let me go back here. All right. All right. Yeah. So I think that's mostly what I wanted to cover. So actually, I just want to show another one here, what you can do once you have it inside of Unity. So for example, some of the components that I have coming in from Revit here, it's missing a material. So I just want to show that, with the extensibility of the Unity environment, like what you can do. So you could create, custom editor scripts that would say, find all like, the different game objects that I have in my scene, and then fix, all the materials that I have, or automatically assign. So you could either use, Pixyz, or you could do it through the Unity editor environment. So for example, in here, if I want to select a material that I already have, and I just want to be able to fix all the different game objects, I can go ahead and run this. It actually will loop through and fix any mesh renderer that's got a missing material, so I don't have to manually go through and assign that. And then using Pixyz, I can always like switch out later and automatically do that from the Pixyz set of toolkit. So let me just pause there. I think that's mostly it on what I have. So I'll actually start taking questions now. So let me maybe go back to my other scene here. Going to not save this.
One question that I answered kind of at a high level, but you may have more specifics, is the hardware specs of the computer that you're using.
Yeah, so on my PC right now, I'm running so actually similar spec to the machine that you have, Cam. So it's a RTX 3080, I believe. So it's on the higher end, but definitely not like the latest, like 4 series or 5 series coming out soon. And then in terms of the CPU, I believe it's an i7. So I would say higher spec machine, but using Pixyz, we can definitely, optimize this so that we would be able to work with a larger data set for machines that's, lower spec.
Awesome. Thank you. And then I see one other that's open that is specifically around VR devices and the ability to simulate different VR devices to understand the types of frame rate that you should expect on different endpoint hardware. Is that a thing that you could talk about?
Um, yeah, so I would say, it really depends on like the actual hardware. I don't know if there's anything that would let you simulate, how capable a device will be unless you load the model onto the device. It's really hard to say, but just the general rule is that if it's going to be able to run on like a light a lighter weight device like the Quest 3 in standalone mode, then the frame rate will probably be around double to could be triple that if you are running it on PC. So that's usually my rule of thumb, is that for anything that I'm able to run on my PC, I would probably have to optimize it, like with a 50% reduction or more in terms of either like the number of game objects or triangles. If I'm wanting to also view it on a standalone device like the Quest, or there's also like a medium um, um, option as well, where you are streaming the content directly to a Quest, and then you're still leveraging the GPU on your main PC.
Awesome. And we have one other that came in asking about taking measurements on the model. So once it's into Unity, how might you go about it?
I'm sorry, what was that one? Taking.
It's asking about taking measurements on the model. So I don't believe there's something built into plugin, but within Unity, kind of how would you go about trying to figure out the measurements of something once it's imported?
Yeah, so there's a few things that we can implement. So if I go ahead, for example, like let's say with this tile here, I can go ahead and make a new cube. So this cube is 1 meter by 1 meter by 1 meter. So that's the default coordinate measurement that we use inside of Unity. So based off of that, we could create a system where essentially using raycast, you can point at a mesh, and then that will spawn a point on that surface, and then we can measure the distance between those 2 points. So you could spawn 2 points, and then that will give us the measurement in meters. And then just using a conversion, we could we could go from metric to imperial, based on that. And also there are existing measurement tools that you could check out on the asset store as well.
Awesome. Thank you.
Let me see if there's anything else I could answer here.
I do see in the chat from Devin, staying on distance, would SF be in the asset store as well? I'm unsure what SF means, but if you could elaborate, Darren or Devin, I apologize. We could answer that for you. Square footage. I do not know. That's a good question.
Oh, like, is there a way to measure square footage within Unity?
Yep.
Okay, yeah, so I think for that, it would probably be similar to how we would do like a measurement tool. So we would, create a polygon and then calculate the area of the sides of the polygon, and then we would be able to, find out like, the area. You can also do like cut and fill as well, like, calculate volume. That would also apply, but that would be, I don't know if, we have anything like that on the asset store, but that would be something that could potentially be built, to create like a, cut and fill and then calculate the volume, like how much dirt you would need to, fill this, like, to fill the hole, or how much you would need, for like a truckload if you need to bring back dirt into the site. So yeah, that could be possible to do. Yeah.
Awesome. Have another one coming in. Is it possible to extrude polygons in Pixyz? For example, having a building layout, a DWG, and would like to create a 3D model of the building walls for VR. So essentially going from 2D flat to 3D 3D polygons.
Yeah, so I would say that, it's certainly possible to create like models inside of Unity. So that would probably either be using Pro Builder, which is our, modeling tool, and then from there we could, essentially create like, like a plane, or, for example, if I want to create a cylinder, I could go ahead and make a new cylinder, and then this could represent like the pipes that I have. So for example, I can go in and rotate this, um, and then, I could position this into place. So, you can see how we could start to, create the as build from the, scans itself. For a DWG file, I know that we will bring in those lines for DWG, but it is not possible to select those edges and extrude from. Now, we do have a new SVG converter that potentially could be something that is worth looking at. So essentially, you could take a DWG and convert it into an SVG. So that will give you additional lines and edges that you can work with. And then in Pro Builder, I believe that you can probably make it so that you are selecting the lines and then creating a polygon from those edges. So yeah, let us take a look at that and see if that would be possible.
Awesome. Thank you. Only other question I see. So Devin just asked, what about for PDFs? So we could address that. And then I also see the question of plans on supporting ArchiCAD files, which might need to be one that the Pixyz team addresses. But the first one about PDF import, perhaps we can throw to you, Leo.
Yeah, so for PDF, I believe that for that one, I haven't tested that actually. I've only done like just like raw images through Unity. Um, I believe that it is supported. Maybe the Pixyz team can chime in on that one. Um, But yeah, I think it is supported, but yeah, we could get back to you on that one. Normally for me, if it's just like a drawing or a layout, I either use just an image background. So in Revit, I could go ahead and just export out like a floor plan view, and then just using, like a PDF, I could go ahead and bring this and link it into the Unity environment just as a 2D image texture, so that we have a background that we could work off of. Yeah.
And it looks like I just pulled up the documentation page for supported file formats. So we do support PDF with Pixyz Plugin 3.0. It does not support metadata import, and it does require, from what I can tell, that it be a 3D PDF to import the data. It wouldn't be a workflow that I'm aware of to pull in like a 2D flat PDF. It would probably go down that same pipeline that Leo was talking about with the SVG conversion or something comparable to a DWG.
Hey Cam, this is Gary. Yeah, I would suggest that you convert that PDF elsewhere to SVG or other, and then you can bring that in that way.
Matthias has a question I might be able to take a crack at, which is around, is it possible for clients to drop their models in with some type of restricted account so we can grab it and import it easily? So there are a few ways to address that. One would be if you were attempting to take something like a Pixyz SDK, that's the headless automated version of this, and expose it to external customers or clients of yours. That would be something that you'd want to talk directly to your client partner about at Unity and make sure that all the T's are crossed and I's are dotted as far as everything staying completely within the terms and whatnot of using Pixyz in that fashion. But there are ways to get something like that to work. The way that I would handle that is likely leveraging something like Unity Asset Manager that we covered in episode 1 for a little bit, and Brian Baer will mention as well in the SDK that he's going to be doing very shortly. And I would essentially get customers or clients into having some sort of access or license into my Unity Cloud or my Unity Asset Manager so that they could drop assets up there. But there are a number of ways to approach it. You just want to make sure that you talk to somebody on the Unity side of things to make sure that everything's staying in compliance, everything's good to go, all on the up and up. But theoretically, it is possible. Ah, okay. Yes, exactly. So with UAM, it would be something that would likely be a whole separate webinar. But in short, there are different levels of access to Unity Cloud. So you can have full access with people who are leveraging Unity, that are inside of Unity Editor and needing to upload and edit assets. There are other levels of access that can simply download or access very simple rights to different types of models in your asset manager. It would be worth kind of diving in further with your CP client partner, that is, or your PRM, your partner relations manager, and getting more details on that. Typically, the ability to upload is reserved for the higher level of access, and the ability to download is for the more restricted level. But I'm certain that there's something we could figure out together. Wes has the question of, are these recurring Pixie sessions building on each other with different content? This is the first session I was able to attend. And yes, that's a great example. So you downloaded the 7-cylinder radial engine asset for more engineering workflows. That is stuff that was covered in episode 2 and perhaps even a bit in episode 1. There are also a couple other tutorials online and through Unity Learn that reference that asset in particular. So I would go back and reference those. These do somewhat build on top of each other, but they're more so different lenses with which to look at Pixyz. So last week was engineering, this week is architecture. Brian, in I believe 2 weeks' time, is SDK, which is automation and headless. And then the final week will be Gary hopping in for industry assets that you could get to on the asset store and things like that. So they don't necessarily go in a linear order, but they do all kind of build on each other as far as capabilities. I think that might be it on questions, Leo. I'm scanning right now. If there are any last ones that want to slide in here at the end, feel free to do so. But I'll hand it back over to you, Leo.
Okay, sounds good. I think if that's all the questions that we have, we can end a few minutes early. Yeah, feel free to reach out to us. We're happy to take questions, and looking forward to seeing you guys back on the next one. And that one will be covered by Brian Bear on the Pixyz SDK. And yeah, appreciate everybody tuning in for this webinar, and you guys have a good rest of your day.